Hello everyone. So today we are going to discuss Unit 1, okay, which is parametric and non-parametric statistics. Okay, so basically we will study two types of statistics which are used in this statistical studies. That is, first is parametric statistics and the second is the non-parametric statistics. So the basic difference between the so basically what we do, we make certain assumptions about the population. Okay, so like we make an assumption that the population follows a certain distribution. Okay, so what do non-parametric statistics do? They do not make any assumption regarding the population. Okay, whereas in parametric statistics, there are some assumptions regarding the population. We'll study each of these in detail as we move along this unit. So let us start. So the objectives of this unit are that after reading this unit, first of all, you will be able to define the terms, what are parametric statistics and what are non-parametric statistics. Then we'll also study what are the basic differences between the two. Okay, where are parametric statistics used, where are non-parametric statistics used. Okay, where parametric statistics is suitable, where non-parametric statistics is suitable, and so on. And then we will also study the nature and meaning of parametric and non-parametric statistics. Okay, and not only this, we also study what are the assumptions of parametric statistics, what are the assumptions of non-parametric statistics. And we'll also discuss what are the advantages and disadvantages of parametric statistics and non-parametric statistics. So these are some of the objectives of this unit. So this unit is basically more of a theoretical unit. In this unit, you will study the introduction to parametric and non-parametric statistics. So as I told you, you'll study what is the definition of parametric, non-parametric statistics, what are the difference between the two, what are the assumptions of the two, and then you'll also study the advantages and disadvantages of parametric and non-parametric statistics. We'll also study some of the tests which are used in these parametrics and non-parametric statistics. However, you should note that we will not go into the details of those tests. Okay, we will study whatever is given in this unit. You should just know what are the, for this unit, for the time being, you should know what are the tests to be used in the parametric and non-parametric statistics, and we'll study each of the tests if it is there in your syllabus in the appropriate units. Okay, so then we'll start with the introduction of parametric and non-parametric statistics. Okay, so let us start with the introduction and go into the detail of this unit. So now let us study about the introduction. So basically, in this unit, we'll study various aspects of parametric and non-parametric statistics. Okay, what is a parametric statistical test? A parametric statistical test specifies certain conditions such as data should be normally distributed, etc., or any other distribution. And the non-parametric statistics, it does not require the condition of parametric statistics. Okay, in fact, non-parametric tests are known as distribution-free tests. Okay, so this basically we will be focusing on parametric and non-parametric statistics. So basically for making inferences about various population values or parameters, we generally make use of parametric and non-parametric tests. Okay, so in this section, in this unit, we'll study the concept and assumptions of parametric test. Okay, and we'll also study the advantages and disadvantages of parametric and non-parametric statistics. Okay, so basically when you use parametric test for making statistical inferences, we need to take into account certain assumptions about the nature of the population distribution and also the type of the measurement scale used to quantify the data. In this unit, we will learn another category of tests which do not require stringent assumptions about the nature of the population distribution. So this category of tests are called distribution-free or non-parametric tests. Okay, we'll touch upon some tests, non-parametric tests like chi-square, median test, Mann-Whitney test. Okay, and so on. Okay, so this was about the introduction, and now let us start with the definition of parametric and non-parametric statistics. Okay, Now let us study the definition of parametric and non-parametric statistics. Okay, so statistics is an independent branch and its use is highly prevalent in the fields of knowledge. Okay, many methods and techniques are used in statistics. Okay, and these have been grouped under parametric and non-parametric statistics. Okay, so statistical tests which are not based, okay, which are not based on normal distribution of data or any other distribution assumptions is not there, then such tests are known as distribution free test. Okay, and in such data, in such type for such tests, the data is generally ranked or grouped. Okay, examples include the chi-square test and the Spearman's rank correlation coefficient. Okay. So this is the definition of non-parametric statistical test. So basically, let us study more detail about the non-parametric techniques. So the first meaning of non-parametric technique, it covers, so the first meaning of non-parametric, it covers techniques that do not rely on data belonging to any distribution, as I told you. Okay, so they do not take any distributional assumption. Okay, so in non-parametric statistic, there is no distributional assumption. Okay, and so these include like distribution free methods, non-parametric statistics, no assumption of structure of a model, which is subdivided into non-parametric regression and non-parametric hierarchical Bayesian models. And fourth, the assumption of a classical or standard test are not applied to non-parametric test. Okay, then we'll discuss all of these points in brief. So let us come to distribution free methods. So here, as I told you, that this means that there are no assumptions, okay, that the data has been drawn from a normally distributed population. There are no such assumptions that is that the data is drawn from a normal population or any other distribution. Okay, so this consists of non-parametric statistical models, inferences, and statistical tests. Then coming to non-parametric statistics. So in this, the statistic is based on the ranks of the observation. Okay, the statistic is based on the ranks of the observation and do not depend on any distribution of the population. Then third is there's no assumption about the structure of the model. Okay, so in non-parametric statistics, the techniques do not assume that the structure of the model is fixed. Okay, no fixed structure of the model is taken, is assumed, and then what happens that in this type of non-parametric statistics, individual variables are typically assumed to belong to parametric distributions. Okay, and assumptions about the types of connection among variables are also made. Okay, so so here these are subdivided into non-parametric regression. And what happens in non-parametric regression? That the structure of the relationship is treated parametrically. Okay, and so in regard to Bayesian models, these are based on the Dirichlet process, which allows the number of latent variable to grow as necessary to fit the data. So Bayesian model and Dirichlet process, these are subjects of higher or advanced mathematics. So till now only just need to know that these techniques are based on non-parametric regression and non-parametric hierarchical Bayesian models. Okay. So here the fourth point is the assumption of a classical or standard test are not applied to non-parametric tests. So the assumptions of classical or standard tests, they do not hold true in non-parametric tests. Okay, so these were this was about the non-parametric test. Now let us consider the parametric test. Okay, so parametric test, they normally involve data expressed in absolute numbers or values rather than ranks. Okay, an example is the student t-test. Okay, so like the parametric statistical test, they operate under certain conditions. Okay, and since these conditions are not ordinarily tested, they are assumed to hold valid. Okay, And the meaningfulness of the results of a parametric test, it depends upon the validity of that assumption. Okay, and proper interpretation of the parametric test based on normal distribution also assumes that the scene being analyzed results from measurement in at least an interval scale. Okay, what is interval scale? What is ratio scale? We study later. Okay, so an example of parametric tests are like t test, z test, and f test, and so on. Okay, so before getting into t test, z test, and f test, you should also know what is population. Okay, so population refers to the entire group of people, okay, which a researcher intends to understand in regard to the phenomenon. The study is generally conducted on a sample, okay, of the set population, and then the obtained results are applied to the larger population from which the sample was selected. Okay, so we'll cover in brief about t-test. So t-test basically here, t-test is used to determine if the scores of two groups differ on a single variable. Okay, so basically a t-test is designed to test for the differences in mean scores. Okay, so for instance, you could use t-tests to determine whether writing ability differs among students in two classrooms, etc. Okay, and it may be mentioned here that the parametric tests like maybe f-test or t-test, they are considered to be quite robust and are appropriate even when some assumptions are not met. Okay, so parametric tests are useful. Why? Because these tests are most powerful for testing the significance of trustworthiness of the computed sample statistics. So we compute the sample statistic from the sample data and then we use the parametric test to test the significance or trustworthiness of those computed sample statistics. Okay, however, their use is based on certain assumptions. These assumptions are based on the nature of the population distribution and on the way the type of scale is used to quantify the data measures. Okay, so we study what is scale and what are types of scale in the next slide. Okay, so there is a small correction here. So when we are talking about the no assumption on a structure of a model, it is divided into two parts, that is non-parametric regression and non-parametric hierarchical Bayesian models. So non-parametric regression in basically non-parametric regression, the structure of the relationship is treated non-parametrically. Okay, it is not treated parametrically, it is treated non-parametrically. Okay, this was a small correction. And now let us move forward to the scale and its type. Okay, now let us study about the scale and its types. Okay, so basically there are four types of scales used in which are used in measurement. Okay, so these are the nominal scale, the ordinal scale, the interval scale, and the ratio scale. Okay, so let us start with nominal scale. Okay, so in nominal scale, what happens? That nominal scales deals with nominal data or classified data. Okay, so it deals with nominal data or classified data, such as, for example, the population divided into males and females. Okay, so there is no ordering of the data in that. Okay, and it has no meaning when we say that male is greater than female. So this statement has no meaning. Okay, these data are also given arbitrary levels. Okay, so these data like male you can give M and female you can give F. Okay, and or you can represent M by 1 or F by 0 or M by 0 F by 1, whatever you wish. So these are also known as the categorical scale. Why? Because these scales are the scales with values that are in terms of categories. Okay, because here categories are involved rather than numbers. Okay, then coming to the ordinal scale. Okay, so ordinal scale it deals with the ordinal scale it deals with the interval data. Okay, so these are in so this deals with interval data. So these are in certain order, but the differences between the values is not important. Okay. For example, the degree of satisfaction ranging in a 5-point scale. Okay, if there's a 5-point scale ranging from 1 to 5, then 1 indicates the least satisfaction and 5 indicates the highest satisfaction. So such a scale is denoted as ordinal scale. Okay. Then third we come to the interval scale. So basically interval scales deal with ordered data. Okay. Ordered data with interval. Okay. So this is a constant scale, but it has no natural zero. Okay. It has no natural zero. And here differences do make sense. For example, so example of this kind of data includes, for instance, temperature. So example can be temperature in centigrade, in degree Celsius or Fahrenheit. Okay. So so this is an example of interval scale. Here in this zero doesn't make any sense. Okay, like the dates in the calendar here, that dates in the calendar also zero does not make any sense. Okay. And interval scale possesses 2 out of the 3 important requirements of a good measurement scale. What is that? That is magnitude and equal intervals. Okay. But as I told you, it lacks the real or absolute zero. Okay. It lacks real or absolute 0 point. Okay. Then coming to ratio scale. So here ratio scales, it deals with ordered constant scale with a natural zero. Okay, so it has a natural zero. Example of this type of data includes, for instance, like height, okay, weight, age, length, etc. Okay, so you can like say like this zero height, you can say zero weight, zero age, zero length, and so on. Okay, now the sample with small number of items are treated with non-parametric test because of the absence of normal distribution. So basically when there are small number of items, then condition of normal distribution may not hold. So in that case, non-parametric statistics are used. Okay, so for example, if our sample size is 30 or less than 30, 30 or less, okay, the sample size is 30 or less, that is n is less than equal to 30, okay, then you can use non-parametric statistics. Okay, and non-parametric statistics can be used for nominal data along with ordinal data. Okay. So basically, what is a non-parametric statistical test? So a non-parametric statistical test is based on model that specifies only very general conditions. Okay, and none regarding the specific form of distribution from which the sample was drawn. Okay, now there are certain assumptions which are associated with the non-parametric statistical test. Okay, namely that like some assumptions are like observations are independent. Okay, so observations are independent, perhaps that the variable under study had underlying continuity, but such assumptions are fewer and weaker than those associated with parametric test. So there are weaker and fewer assumptions which are associated with non-parametric test as compared to parametric test. Okay. Moreover, as we shall see that non-parametric procedures often test different hypotheses about population than do the parametric procedures. Okay. And unlike parametric test, there are non-parametric procedures that may be applied appropriately to data measured in an ordinal scale or in a nominal scale or in a categorical scale. Okay, and as I told you that non-parametric statistics, it deals with small sample sizes. Okay, and basically, yeah, and so non-parametric statistics are assumption free, as I told you that meaning these which means that these are not bound by any assumptions. And non-parametric statistics are also user-friendly as compared with parametric statistics, and they are economical in time. Okay. So we discussed that the parametric tests are generally quite robust and are useful even when some of the mathematical assumptions are violated. Okay. However, these tests are used only when the database is based on ratio or interval measurement. So for parametric test, the data should be based on ratio or interval measurements. Okay. Now, in case of counted or ranked data, we make use of non-parametric tests, as we discussed. Okay. So it is argued that non-parametric tests have greater merit because their validity is not based on any distributional assumption. Okay. Because such assumptions are frequently ignored or violated by researchers who use parametric tests. Okay. And non-parametric tests are also less precise and has less power than the parametric test. Okay, so these were some of the differences which you can write between parametric and non-parametric test. Okay, now let us study some assumptions of parametric and non-parametric statistics. So we will start with assumptions of parametric statistics. Okay. So parametric tests like T and F test, they may be used for analyzing the data which satisfies the following conditions. First is the population from which the sample has been drawn, it should be normally distributed. Okay, normal distribution refers to a frequency distribution following a normal curve which is infinite at both ends. So normal distribution looks like this and it is a symmetrical distribution. Okay. So basically it looks like okay, and it is a symmetrical distribution. Okay. So these are drawn the normal distributions. Okay. I'll draw it again. This is a normal distribution. A shape, it is a bell shape. Normal distribution has a bell shape. Okay, and it is a symmetrical distribution. Now, and it is basically infinite at both ends. Go like this. Okay, so it is infinite at both ends. Okay, and it has a bell-shaped curve. So the variables involved must have been measured. So the second assumption of parametric test is that the variables involved must have been measured in interval scale or ratio scale. Okay. Now, the observations must be independent. Okay. And the inclusion or exclusion means, what do you mean by this? The inclusion or exclusion of any case in the sample study or any observation in the sample study should not unduly affect the results of the study. Okay. The next assumption is that these population must have the same variance or in some special cases must have a known ratio of variance. Okay. This is known as homoscedasticity. Nothing. Okay. So this is known as homoscedasticity. So when a population has same variance, okay, or in some special cases they have a known ratio of variance, then this is known as homoscedasticity. Then the samples have equal or nearly equal variances. This condition is known as equality or homogeneity of variances and is particularly important to determine when the samples are small. Okay, so this was homoscedasticity and this is homogeneity. What happens in homogeneity? The samples have equal or nearly equal variances. Okay, so this condition is known as equality or homogeneity of variances, and it is important to and it is particularly important to determine when the samples are small. So you must see that it satisfies this property. Okay, then we will study the assumptions of non-parametric statistics. Okay, and here one more assumption is that the observations are independent. This I've already told you. Okay, and which means that the inclusion or exclusion of any observation it should not affect the study results. Then let us study the assumptions of non-parametric statistics. So If our sample is in the form of a nominal or ordinal scale and the distribution of sample is not normally distributed and also the sample size is very small, it is always advisable to make use of non-parametric tests for comparing samples and to make inferences or test the significance of trustworthiness of the computed statistics. Okay, so in other words, use of non-parametric test is recommended. Okay, in the following situations. So first of all, that these so what are the assumptions of non-parametric statistics? First of all, that as I told you, what are the situations in which the non-parametric test is recommended? First is when the sample size is small. Okay, when the sample size is small, like n is equals to 5 or n is equals to 6. Okay, then the only alternative is to make use of non-parametric test. Okay, and when assumption like normality of the distribution of scores in a population are doubtful or there cannot be made any assumption about the distribution, then we can use non-parametric test. Okay, and when the measurement of data is available either in the form of ordinal or nominal scales, okay, or when the data can be expressed in the form of ranks or in the shape of like plus signs or minus signs and classification like good or bad, we can use non-parametric statistics. Okay, next we'll study advantages of non-parametric statistics. Okay, now let us study the advantages of non-parametric statistics. Okay, so if the sample size is very small, there may be no alternative except to use a non-parametric statistical test. Okay, so non-parametric test typically make fewer assumptions about the data and may be relevant to a particular situation. Okay, so they make fewer assumptions. Then the hypothesis tested by non-parametric test may be more appropriate for research investigation. And then the third is the non-parametric statistical tests are available to analyze data which are inherently the data which are inherently in ranks as well as the data whose seemingly numerical scores have the strength of ranks. So the data which is in the rank form for that non-parametric test are quite suitable. Then what are the other advantages? Samples made up of observations from several different populations at times cannot be handled by parametric test. Okay. And so, so basically, so non-parametric tests basically are typically much easier to learn and to apply than a parametric test. Okay. In addition, their interpretation often is more direct. Okay, than the interpretation of parametric test. Okay, so like this data is more useful for the day for the this type of test are more useful for the data which is in the form of rank. Okay, so for example, let us see in studying a variable such as anxiety, we may be able to state that subject A is more anxious than subject B without knowing at all how much more anxious A is. Means we do not require a number, but we know that the subject A is more anxious than subject B. Okay. Thus, if the data are inherently in ranks, or even if they can be categorized only as plus or minus, like plus for more or minus for less, better or worse, etc., then they can be treated by non-parametric methods. So these are some of the advantages of non-parametric methods. Now let us see some of the disadvantages of non-parametric statistical test. Okay, so if all the assumptions of a parametric statistical model are in fact met in the data, okay, and the research hypothesis could be tested with a parametric test, then the non-parametric tests are usually wasteful. Okay, and the degree of wastefulness is expressed by power efficiency of the non-parametric test. Then the next is another objection to non-parametric test has to do with convenience. Okay, table necessary to implement non-parametric tests are scattered widely and they appear in different formats. So the tables are widely scattered and they are in different formats. However, this is true for some of the parametric tests also. Okay.